if you heard about like the VLSI is booming nowadays, like semiconductor industry is booming now. So we'll see that why it is important. So we'll go through the presentation. So I'll go through the PPT and I will explain the things. If you guys have any queries, so you can raise the question there itself, or else at the end of the session, you guys can also ask the questions. Okay. Like any queries before starting the presentation? So this I'll share. Is slide is visible for everyone?
Yes.
Yeah, thank you. I heartily welcome you guys for the physical design demo on behalf of the Success Bridge. So this is a training institute which is providing on like a VLSI domain. It's like not in the only particular on the physical design, on the various courses will be provided in the VLSI. So that we'll go through one by one like later. So this today we'll conduct the demo only on the physical design. So we'll see that what is the physical design and what are the career opportunities, and later like how the industry is booming and why it is so. And also that like before going to that physical design, first we'll look into the what is VLSI. So in this agenda like today demo, so we'll see that why VLSI, introduction, and later like inside the VLSI the physical design will come. So we'll look only the introduction level, so overview of the physical design. If you do the course in the physical design, what are the opportunities you will get and how the industry is going, so that we'll see in the VLSI, and what is the scope of the semiconductor. Later we can go through the question and answers. So next, why VLSI? So if you anyone can say me like what why you guys are so interested in VLSI, why it is so? Anyone? Okay. If you see the how the market is booming, so you can see from this slide from the 1987 to just I took from 2020, not like up to date. So the whatever the growth you can see in the market is like a increasing like exponential, right? So why it is so? If you see that in 1987 it's like a billion, like it is not even like $100, it is like a below $100. If you see that now the market is almost reached up to like $500 billion. So why it is so? Like if you compare the software and the semiconductor, it is not the same. If in the current industry, like in the current present era, the everyone are talking about the semiconductor. Why it is so? So we can see that like in the earlier days how the instruments was or the equipments was. So if you see that in earlier days whatever the electronic devices we were using, that is like a very huge. And if the whatever, for example take it as a TV. If you see the TV in the earlier days, just take like a 10 years back, not more than that, just take a 10-year back, like 2010 10 to 15 years back, the TV we were using, it is like a dome shape, right? So if the TV is having a dome shape, it means that inside that you will be having a many electronic instruments, which where the size of that components were very huge. So that is why the TV size is like a dome shape and it is consuming the more area in your in your home or wherever, like a workspaces, wherever it is. So if you're involving those many electronic components inside the TV, it will consume more power, because all the all the instruments which are in a which you kept inside, it needs some power, so to turn on those devices. So if all the equipments, all the electronic devices, it's like consuming more power, it means that it was dissipating more heat. If you just science, like if you guys like just in your like most of the things, like if you are in a current like academics in your childhood, if you saw your TV, if you just kept your hand on the TV, you can sense some kind of heat, right? So also, if you want to shift from one place to another place, your TV, it is not so much reliable, because it consumes, it is like a weight, it will be having a weight. So these were like a earlier days, because in that time it was not too much involved in the industry. But nowadays you can see that whatever the devices you can see, let's assume the TV itself. You guys are LCD TV, LED TV, which you will hang in your wall. So what happens, like when the thickness of the TV is also, it's like so slim, right? If you see like a higher version of the TV, it's like only like a glass. So what they have introduced in the technology, they are using like involved in the technology, they have reduced so many equipments and the size of the equipments. So whatever it is not necessary, just they are discarding, and they are using as much as possible, like a reliability wise. So when you are using the TV, it's like a portable wise, it is very easy, and the like it is not taking the spacious in your home, and whatever the thickness has reduced, it is because of the whatever the circuits which has used inside, that size got reduces. So since the size got reduces, it will not consume so much of power, and it is not take that much of heat, it will not that much dissipate the heat. So it is very easy for the application wise, it is very easy for the usageable, reliability wise. So this is why like the industry is booming. So if you see that, like this is a, you can see that this is a hard drive which the IBM was shipped in 1956. You can see that it is just a 5 MB hard drive. They are portable, like they are shipping from one place to another place. You can see that how many people have involved in that. It is just a 5 MB drive, hard drive. So you can see that like just for the 5 MB hard drive, these people are struggling like anything. Nowadays, we are carrying in like a GBs in our hands, nothing but ever in a mobile. Or if you say that like compared to this one only, just in a like a, this is like a, you can see that in a TB you can just carry your hard drive, right? Whatever the information to store, we want to store like a flip card and the hard drive, it is very like the cost also, it will be like anything like like billions. You can see that it is just like a 5 MB hard drive to, for the shipping cost it may cost like $1 billion. Nowadays it is very easy by the by using the VLSI advancement. By using the VLSI advancement, whatever the components it got reduces, and you can easily the TB of a hard drive nowadays. So this is what the VLSI is. Whatever the components are, the size or the reliability voice, application voice, it is enhancing and it is easy to use, right? It is because of the VLSI. And the VLSI is advancing every year, growth on growth. So we'll see that what is VLSI. We are saying that it is due to the VLSI, VLSI, VLSI. Then what is VLSI? So the VLSI is a very large scale integration. it is like a within a IC, sorry. IC is nothing but a integrated circuit. So here we will be having like a small scale, medium scale, and the large scale, and the very large scale, ultra large scale. So on what basis we are saying like a small scale industry, medium scale industry, large scale industry, and the very large scale? Based upon the transistors which were used, based upon that we are saying that a industry, like a small scale industry. If it's a small scale industry, whatever we are using the transistors, if it is like a within a range of 10 to 100, so it we call like a small scale integration. When go to medium scale, if the transistors are between like a 100 to 1000, it's a medium scale. It is just if we compare the industry, right, like small scale industry, it is the same way, like how you guys are doing like a small scale industry, medium scale industry, large scale industry, right? On the same basis, if the transistors are like within 100 range, it will be the small scale. If the range between like 100 to 1000, it's like a medium scale. If like the transistor size varies between like 1000 to 10,000, it's a large scale industry, sorry, integration. Very large scale, it means that it's like more than 10,000 transistors which is involved in your IC. So that is a very large scale integration. Next comes to the ultra large scale integration. It is not so popular because it didn't achieve that much. It is more than like a billion transistors that we used. So it is not so popular. It didn't came that much of success when compared to the very large scale. So that's why we are using the VLSI. Next, any doubts in the like what is VLSI? Introduction to VLSI you wanted to know? Okay. Then in ICs, we'll come in a three categories. Whatever the ICs we are talking, right? It is not like a only one flow. It will be having a three categories. So in ICs integration, it will be having a three. Like one will be the ASIC, another will be the FPGA, and other will be the microprocessor. In whatever we are seeing, right, the physical design and the DFT, DV, we are using most in the ASIC. So whatever you guys will come into this one, right? It's a ASIC, application specific integration circuit. So will the FPGA is nothing but the it's a field programmable gate array. You can see in your motherboard, whatever the things, right? You will be having a kits in your academics. So it will be most upon the FPGA. And next, you guys, I think you guys are familiar about the microprocessor. So we'll just compare the what is the ASIC, FPGA, and the microprocessor. In coming to ASIC, here whatever the circuits which are fabricated on the silicon is fixed. You can't change it. So it is not so flexible. It will be fixed. And since you guys are making it a very compact, it will be work on your low power. And on the single wafer, you can integrate many ICs on the single wafer. So the wafer is nothing but you are like a plate. On the plate, single plate, you can fabricate many ICs, like compared like 1,000 ICs and all. And so on this, that is what it's like a cheap on high volume. So small size and a fast. You can see in your ICs, right? It is like a very minute, very small, and the fast will be, it will be like a having a very, the speed will be more. To gain this one, you guys need the knowledge on the Verilog, VHDL, C++, or any kind of the scripting language or the programming language, and you should know the digital. Nothing but your logic. You can say either it is a logic design or in a digital circuits. You should have the knowledge on this one minimum. Next, coming to the FPGA, here the circuit will be flexible and it's like a, it is also fabricated on the silicon, but since the size of the circuit will be more, it will consume more power. And it is like a low, since the size is very more, right, you can not fabricate many things. If you're fabricating ICs like a ASIC ICs on like 1,000, in the FPGA you can make it like a 700, 500. That's it. And it will take fast more time to implement. And also, coming to the knowledge wise, it requires the knowledge on the application like Verilog, VHDL, C++. Next, the processor, microprocessor. Microprocessor, you guys know about in the academics. Circuit is flexible, and for this one, you guys need the programmable, and it will be require the more high power. And when coming to the size wise, and this will be cheap, and when it's a very slow, and it is easy to use. And the knowledge wise, you guys need the C++, and the sum of application you wanted to know. Next, you can see the IC chip. So this is a IC chip. It will be like a very minute. These all, like you can see that these all like a pins, and this is a IC you guys need to work on. So for this one, to implement this one, you guys need the knowledge on the VLSI. So inside the VLSI, we will be having the PD. So by using those things, you can design it. Next, you can see how the generation is going on in the industry. Before it was like a 18 nanometer and 90, 65, 45, 32, 22, 14, 10, 7. Nowadays, we are working on like a 3 nanometer and 2 nanometer, 1 nanometer also. They are charging, they are taking in the 1 nanometer technology. So what is that nanometer technology? How it depends, how it varies. So as the you guys heard about the Moore's law, right? What the Moore's law says? Anyone? Anyone knows about the Moore's law? It stays as like every 18 months the transistor get doubles. The transistor get doubles means here you can see that we are like every like nanometer is like coming from 180 to 90, right? Here the transistor size get doubled. It is the nanometer technology is advances. That doesn't mean that we are not like we are reducing the number of transistors. It is not like that. We are increasing the number of transistors and reducing the technology, advancing the technology. So that what does it nanometer? The technology depends upon the nanometer, like 3 nanometer, 1 nanometer, right? It is depends upon the gate, W and the L, width and the length of your transistor gate. So we will reduce that the gate and the width, will making the compact in the width and the length of the transistor. So by achieving this one, we are going to the advancement of the technology. So that is why the transistor gets doubling. Next, inside the VLSI, now we'll go to the physical design. So this is how your chip works. In the physical design is nothing but it's a physical implementation. Whatever you have the things, you need to arrange it and you need to process it. So how the VLSI comes means first you need to get the concept. For that, nothing but this concept is nothing but your requirements. For that, you need to design it. So if whatever the customer comes, he will give that I need this and all. So for that one, you will go through the RTL design. Nothing but they will design it. So after that, after designing, you guys will verify it. So that is nothing but the RTL verification will come. So after that, the synthesis people will generate the net list. So they will check that whatever they have verified, they will make it a simplification. So that, and they will generate the net list that goes to the physical implementation. The physical implementation is nothing but the physical design. So in the physical design, we'll go through I'll explain that what is physical design. So in that, whatever you are getting, you will arrange it and you will process it, you will execute it, and you will send it. So in the sign off, they will verify all the things, whatever you have implemented the design, right? So that they will verify, and then it will go to the fabrication team. So fabrication is nothing but whatever you have did the design, right? They will implement it. So these all the device will come, like ICs will come. So after that, it will go for the testing and the packaging. So after that, here we'll see that the design flow, physical design flow. So here, first, when will the people will come with the chip specification? If suppose whatever it is, like a automobile industry or the analog industry, whatever it is, they will come with the requirements. I need the these kind of specification. The speed should be this much, and the like I this should be work like this. Whether it's for the mobile, automobile, whatever the processor it is. So they will come with the chip verification, sorry, chip specification. Once you make the specification, suppose similar way, take in the like construction industry, take that you having the site, inside that you want to construct a home. So what you guys will do, you will take the site and you will have the proper, you will go to the engineer and you will say that I need this kind of construction. The same way, when you are going to the engineer and you are saying these specification, the similar way the customer will come and say their specification. After that, they will do the design for that one. They will code the RTL design guy, the RTL design guy, the design engineer will write the code. So for that, after that, the functional verification or the DV guys, they will verify it after designing whatever. Suppose you have the AND gate, the AND gate is like a 1 into 1 is like a 1 into 0 is 0. So for that, the functional verification or the DV guys, what they will do, they will insert the physical, like different test cases, nothing but they will check like 0 into 0 is 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. So the similar way, they have put all the test cases and they will verify that whether the AND gate is working properly or not. So that is nothing but the verification. After that, this will go to the RTL synthesis. So they will verify everything, whatever you have designed in the test cases, they will simplify it and they will give the net list. So that net list will go to the partition, they will make the partition of the chip, and after that it will go to the DFT team insertion. So once the DFT's net list is gone, so they will verify that whatever the it is there, it is working properly or not. So then it goes to the physical design. So physical design will start from the floor planning, placement, clock tree synthesis, routing, functional verification, and the GDS2. The floor planning is nothing but the memory will be given and the block will be given. Inside the block, you need to place all the memories inside the block. When compared to the construction, like you have the layout, inside the layout, what you have to do, you have to make the partition, like where should be the kitchen, where should be our veranda, where should be our hall, TV hall, dining hall, bedrooms, right? Where we are making the plan, you will be sitting the appropriate where should be it is. The same way, inside the block, you will be placing all the memories properly. So that is nothing but your floor planning. Next, after floor planning, you need to do the power planning. Nothing but after you making the rooms, you need to do the power supply, right? So a similar way, we'll like we'll do the power planning and we'll call for all the cells. It should send the power. Next, we'll go for the placement stage. Placement stage is nothing but you will be having some other standard cells that it should place inside the block. before, once you get the netlist, all the cells which should be outside the block, you should place inside the block. That you don't have to do manually. The placement stage, the tool will do. So after the placement, you have to check a few, like few steps will be there that you need to check, like congestion is nothing but how the congested it is, whether to sit the place, like the standards are already placed, whether it is placing properly or not, that you guys need to check, whether it is sufficient amount of place is available for those cells or not, that you need to check after the placement stage. So after the placement, the clock tree synthesis. The clock tree synthesis is nothing but for the each and every cell, you need to supply the clock, because you guys are these whatever the memories or the cells, you guys are working on the flip flops, right? For that one, you guys need to send the clock. So for that, the tool will build the clock tree. After that, you have to verify the timing. Nothing but, like, if you're sending the data in a 1 nanosecond, it should reach within a 1 nanosecond, right? So you need to check that within a 1 nanosecond your data is receiving or not. That you need to check in the clock tree synthesis. So after the clock tree synthesis, the it will come to the routing stage. The routing, it means that you are making the connection to route for all the cells. Then in the similar way, the how the road is there, right? It is making the connection from one place to another place, the path. So that is nothing but the routing stage. Next will be the final verification. The final verification, here you need to check the like some DRCs, like it will be they will be having some rules, like from one net to another net, the space, it should have some follow the spacing rules and the timing, all that you need to check it in the final verification. Next, after that, it will go to the GDS2. Any doubts here? Okay. So here you can see that this is a NAND gate, how the it is implemented. So this is a circuit. You can see that this is a CMOS, this is a AND gate symbol, sorry, NAND gate symbol, and this is a circuit in the CMOS logic level. That it will come into the like layout level. So this will be in the layout level. So here you can see this is your block. So whatever this NAND gate, right, it will be outside this one, outside the block. So being a physical design engineer, you will place all the gates inside the block. Here you can see these things, right? So you don't make a like panic, like all the things we need to do manually, you don't have to do that. The tool, there is a separate tool. Most of the things the tool will only do it, like whatever you have the standard cells, everything, right? The tool will place everything, but you should ask the tool to do it. Next, this will be the flow. So how the flow it will go, like first to start the physical floor plan, I said like a floor plan is nothing but like to place all your memories inside the block, right? So here, for that, you guys need some inputs. Suppose whatever you guys wanted to do, like in order to like construct a home, like to place it, right, you guys need some inputs, right? You guys need the like cement, water, the people and the site, everything you guys need, right? In the similar way, to start the floor plan, here we need some inputs like SDA, SDC, nothing but here you will be having the all the clock, because you wanted to build a clock tree, right? So for that, you guys need the clock, nothing but time, your frequency, what is the frequency of your chip, how many clocks you require, that all the information which will be present in your STC file. Next will be the UPF file. So here you guys need the power domains. So that information will be contained in the UPF file. Next will be in the scan and next will be the def lips and the tech is nothing but your technology file. Here you guys will be having like what are the metal layer information, so that will be present in the technology file. I'm just briefing about this one, so that's it. Don't worry and don't panic, okay? And here the lips is nothing but inside the lip you will be having all the information about the your temperature, transition time, pvt corners, everything will contain in the lips. Next, once you get all the inputs, you will go with the floor plan. Floor plan is nothing but placing all the memories or the macros inside your block. So for that, you will be having a set of rules how to place the macros and all. So based upon that, you will do the floor plan. So your block shape might be anything, whether it's a square, rectangular, L shape, U shape, T shape. It might be anything. It will be on the chip level condition. So after that, once you place the macros, you have to go to the placement stage. In the placement stage, whatever the rest of the standard cells will be there, right? So those the tool will place inside the block. The placement, you don't have to do it manually. The tool will itself do the placement of all the standard cells. So after that, it will do the optimization. So how the placement happens means the tool will place all the standard cells inside the block randomly. So after that, in the optimization level, what the tool will do, it will place all the standard cells very neatly, and the like inside the row, there will be a row. For that, it will place all the standard cells. So after that, it will build the clock tree and it will go for the optimization. So here you guys need to check for the timing. After that, you'll go for the routing. The routing is nothing but it will make the connection. Like one standard cell and other two cells will be there, right? So for that, it will make a connection. So after that, it will go for the chip finishment and the sign off. So this is about the physical design flow. And what are the opportunities and the skills are required for this one? So the opportunities, you can become a front-end engineer, back-end engineer, library developer, or the EDA. So or the tool also. See, these all are like on the overall VLSI. If you want to become a VLSI, like a physical design engineer, you want the skills requirement, like you should have the tool knowledge and the some of the digital circuits and the like whatever the physical design concepts will be there, right? So you should know on that one and the scripting language. And next, this is you can see in the latest trends in the semiconductor industry how the market is booming. So you can see these things like the people will be working on SRAM, DRAM, everything. This is across the worldwide how the industry is. So next, the career growth and the future scope in the semiconductor. Uh, I think this he will take like this thing. I think Kumar will take the session.
Thank you, Arushi. Hey, hi everyone. So myself, Kumar. I'm the CTO of Success Bridge. I'm also a technical person working in the reputed company. So I have close to 12 years of experience in the industry in the semiconductor. I'm a DFT guy actually, but still want to give you guys an awareness on how things happen in the semiconductor. So I'll be taking care of all the queries related to the course, okay, career support, the placement, and everything. Yep. So you guys can shoot out any questions that you have before I proceed. Okay, so please unmute. I will not be able to see your comments in the comment section. Please unmute and speak whatever the queries you have. Okay, so coming back to this course, we have physical design, DFT, and design verification courses. And as of moment, recently we have physical design two batches that parallelly started and finished, and we have placed many of them, and many more placements are going to happen. And the team is currently preparing for the interviews. So, uh, given the opportunity, we are still getting a lot of requirement coming from the our affiliated companies that we have tied up with. They need a lot of engineers and the trained engineers. So we are trying to start a new batch, which is having a strength of around 10 to 15 engineers. Okay. So depending on the number of vacancies that we have in our circle, in terms of the company requirement, we are going to take that many trainees. Okay. So on the salary part, uh, everybody has a basic understanding coming from the peers or your guiding people around you. So in semiconductor, the salaries are pretty much good from the uh, as a fresher, as well as once you reach 3 years or 5 years, your pay is much higher than you expect. Okay, so you can see the fresher salary would be 6 lakhs per annum. Uh, as a very basic entry as a trained fresher from any of the reputed company. And starting from 3+ years, your salary will be minimum of 14 lakhs. Okay, minimum of 14 lakhs as a 3+ engineer, and as a 5+, you will have a minimum of 24 lakhs per annum. So the first 3 years is a struggling period where everybody has to uh, grow up, learn the skill, and prove yourself. And uh, you start bargaining on the salary part when you change a company with a 3+ experience. And with the 3+ years of experience, you have a scope to roam across the world. Any company in any country will start fetching you uh, with the 3+ years of experience. So let's say X person has 3+ years of experience in physical design. Then in a company in Malaysia or Singapore is looking for a senior engineer. You are eligible for that. They help you with the visa process for you, family, or if you're married, that would be with for the family. So with the relocation bonus packages and all, you will be well compensated and will get a high paid package. So the package that I mentioned in the slide but that you're seeing is just in Indian salary base. And if you're moving to any other countries, the pay is much higher. Okay. So as you guys see that semiconductor is growing within India, and we have many fabrication units started in Gujarat and Tamil Nadu. Okay, India is going to become one of the uh, high import and export uh, hub for chip designing and semiconductors. So recently, Apple also started its assembling and manufacturing of its latest mobile set in Tamil Nadu. And the Foxconn is a company that handles Apple within India and other places. Okay, so this course is around 4 months duration. Okay, and extra 2 months is for the placement assistance support, and few people need an extra time to adapt to the course and need some time with the lab, okay, with the tools that we have, okay. So i- on a complete course duration we consider it as 6 months, but actually the course syllabus we will be able to uh, teach you within 4 months, okay. And we have uh, industry-led engineers, senior engineers working in the industry in most reputed companies like AMD, Qualcomm, Broadcom, Intel. Okay, so uh, we bring these engineers, senior engineers, for our trainings. Okay, we have online and offline uh, service. So offline we are starting this year. Previously, because of the COVID constraints and area and traffic considerations, we haven't started offline before. And we have office in Bangalore. Okay, and you can always visit our website, reach out to anybody uh, within Success Bridge. Okay, for any queries and any technical guidance, career guidance, or confusion, you can always request for a call to directly talk to me. Okay. So, any queries that you have? If you want, I can go into stop presenting and go into the comment section if anybody has questions.
Hello.
Yes, please go ahead. Yes.
Uh, sir, can you share? Sir, can you share this PDF? Hello.
Yeah, the presentation that we have just yes, we can share with you. You can
Okay. Sir, what is the
please provide
sir?
please
What is
fill
the
it.
course?
Yeah, for everybody's attention, please fill in the form that was shared in the chart. Okay, so we will be able to communicate to you as well as you can communicate to us, vice versa. So please fill in the form. We will have your details so that we will be able to communicate to you. Okay, everybody, in the form is in the chart. Yes, that's essential. Please go ahead.
Sir, what will be the course duration and fees?
So as I mentioned, course duration is 4 to 6 months of period, and the fee structure is generally very less compared to the market and the tools that we use. We are charging 80K, but we have a discount with for all the new aspirants as we are tied up with the government scheme. So we are providing the course with 65K. So with 4 years of lab access, and until you get placed, we are going to support you.
Okay. Yes, sir. Practical will be there, sir.
Yes, yes, you will have practical labs. So we'll provide you access. There is uh, virtual applications software that you have to install in your laptop. We will do that. So you can access within your laptop anywhere.
Okay.
Any other questions?
Yeah. Hello, sir.
Yes.
Yeah. What are the tools you are providing for the
We
practice?
have a complete synopsis suite. As in the industry, synopsis is a major tool that we use across any companies that we have seen. So synopsis prime time is a timing related tool that do STA. Okay, and the fusion compiler tool and design compiler for synthesis. So synopsis is the most commonly used. So we have tied up with synopsis and we have procured many licenses to start up with. So you will have synopsis licenses and tools to work. Yes.
Okay, sir.
Any other questions? So I see, sorry, let me first answer to one of the questions coming in the chat. Uh, DFT and DV, which one create more job openings? So DFT, DV, physical design, RTL design. So any designation that we have in semiconductor has equal pay as of the moment. Previously, DFT and physical design used to get more paid, and now DV, DFT, PD are paid equally. There is no less, no more. All are being paid very high in the market because, as you can see, more people are needed. Okay, and all the EC or L background people themselves are going into softwares because colleges are not able to procure semiconductor companies coming as a campus placements. So many people are from electronics, those who are studying engineering in electronics and electrical, they are moving on to software. So we have less uh, people in the semiconductor and more need. That is the reason we have high demand, and when high demand is there, we have high pay. Okay, and so we tied up with the government scheme that uh, the recently you have seen central government has started make in India, and in the semiconductor perspective, we have a lot of funding happening, and industries are booming in, and government is asking the training institutes like us to have a liberal price structure, and I think many of the institutes are not following it. They're charging more than 1.2, 1.5 for a physical design course in the industry currently. So we always have a lowest band where we are trying to provide the course in a feasible terms for everybody, and there are many other options in terms of payment. Okay, so which domain will be peaceful? Yeah, I guess the term peaceful is we don't say it as peaceful. It's like a passion that you come into. If you are willing to work and then enjoy, any work domain is fine as long as how you handle and how technically strong you are. So if you're technically strong, you finish your week of work in one day and you move on, play the rest of the days. So we do all of that. Okay. So yeah, we have placement support with many of the companies that we tied up. Uh, Almost 80% of the companies that we have in within Hyderabad, Bangalore, and Pune, we have tie up with these companies from starting from Intel, AMD, Qualcomm, Broadcom. Okay, and uh, any service-based companies that we know. Okay, they see, as I said, we have a huge demand. So one more important thing is in semiconductor, there will not be in-house training. Once you are hired and they provide you training, there is no such thing. So IIT, triple IT, NITs, those who study there and they get placed in any Intel, AMD, Qualcomm, Nvidia companies, they have to do 1 year of internship, and end of the day, if 100 people are getting internship coming from these top universities, out of 100, only 5 or 3 or maximum 10 people get selected. They get permanent into the companies. Okay, in the 1 year of internship, they learn from the seniors. So there is no concept of internal training happening in the semiconductor. So semiconductors are based on the training institutes, and everybody who are interested to come into semiconductor, they have to get trained, and companies will directly hire only trained freshers. Okay. Yep. Uh, Next, is there any course for 1 month of summer vacation or any kind internship related to VLSI? Yes, we are tied up with many of the universities and colleges. We already have finished recently from starting. We started from December, I guess. We finished in the last month many of the internship courses that we provide to the universities based on their need and requirement. And you can also consider it as a scholarship for those who are pursuing final year, okay, BTech or MTech. And in this industry, any academic gap or any domain from BTech or MTech, BE or ME, okay, are welcomed. Let's say your passed out is like around 2021, 20, okay, but still you wanted to pursue your career in semiconductor, you're still welcome, okay. So there is no issue with the gap, academic gap, okay. And any domain in the engineering can work on this, learn this, and pursue your career. You just have to be a trained engineer, and you should clear the technical interview that happens after we show you placement, right? So once you're trained engineer, you will be asked on the purely on the course related information, okay. Offline classes we have depending on the number of strength that we can procure, okay. So how many number of students are willing to have come in offline into Bangalore location? Based on that, we will be able to start offline session. Yes. Uh, so one more, yeah. One more. I think two more questions in the chat. Next, I will answer to everybody. As we will know about the interview process, uh, LSI. I didn't understand um, question. Krishna, I did not understand question. You can speak up. I don't have any coding language. What I should take in course? Okay. Semiconductor, if you are willing to go into RTL, design engineering, and design verification, only then you might be needing a strong Verilog or VHDL skill, okay, that you have learned in the academics. Okay, our semiconductor has a strong, solid basic that we use throughout our career. That is your logical gates. Our things doesn't change in semiconductor. You have to deal with your logical gates, flip flops, latches. That's it. You don't need to learn new things. Okay. The only things that you learn is how to handle the tool. In the entire course, you will learn how to handle the tool because 85% of the work is done by the tool. 15% is that how you handle the tool by going through the tool manuals, okay, and little bit of tickle and perl scripting, okay. So we have to go through that. Somebody sharing the screen, Roman. You can ask me directly. Please unmute and ask me. Any passed outs, any year passed outs can learn this course. Okay, and DFT and physical design, you don't need that strong knowledge on the Verilog, but you should be able to understand, okay, there is a module definition of AND gate, NAND gate. Should understand the Verilog code because you have to deal with end of the day, you have to deal with the code, should know what is a Verilog code. So Verilog VHDL is a basic. You don't need to top up it every year like software. Okay. So one time learning.
Get not,
Yes, Roman. Sorry. Please go
sir,
ahead.
and get not get none get
Yeah.
basic get.
Yeah, we have to use only logical gates in semiconductor. There is no other thing that we do. The transistor. What is a transistor basically? Okay, so how do you are bringing the transistor and to build an AND gate or an AND gate? How many transistors you would need? End of the day, okay, you are going with the CMOS design. Okay, so how many transistors you need? Okay, so you will be converting all this RTL code that you write in
Sure, in
Verilog into
computers,
a proper CMOS design. Yes, Roman, say.
sir, transistor in computer में लगा रहता है ना transistor.
I'm not able to understand your question, Roman, but we have to learn the VLSI design basics. Okay, that is all needed for any domain within semiconductor. But as said, RTL and DV needs more thorough knowledge in writing Verilog code. Okay. So online or offline, the course structure is same. The fees structure is same. No domain in semiconductor can be replaced with ChatGPT because ChatGPT is for software. Okay. Semiconductor is a chip designing. You cannot replace. Yes.
AI software, no? ChatGPT AI software.
Yes, this ChatGPT, AI, all these are uh, the software related things that can replace a software engineer job. In semiconductors, you design a chip on top of the chip. If you have a laptop with a motherboard with all the ICs, then only you can have an operating system and the applications installed. Okay, that can be automated by the AI. But to design a chip, we don't have that automation yet. Okay, we need engineers to. We don't trust uh, the AI to design a chip because we have to do it manually based on our customization and our needed. And there is a lot of things that you have to handle manually, and engineering expertise is needed in chip designing because it is not a fixed thing that you have to handle. Okay, you need a your mobile has to support AI features, then you need to have that logic written by RTL design engineer, and then you test it by DFT engineer, and you convert and synthesize and do a placement and routing by a physical design engineer. Okay, there are things that you can't automate. Okay, so how many hours in a day classes? Uh, okay, so depending on the trainer, you might have weekdays every day in a weekday, in the evening 1 or 2 hours, and or if you based on the trainer and the candidate flexibilities. Okay, on a majority, we take it on weekdays or weekends. So we have availability of the trainer with weekend and weekdays also. Okay, so if weekdays we are doing theory session, weekend we will have a practical lab session. So that likewise, we have flexible that will be discussed once you start your course. Okay, uh, so for those who are already working, few people are already working, want to change their domain, okay, from software to semiconductor. I have trained many people previously. We have many students like this. Um, so they are working, so they are uh, willing to attend to the course in the evening sessions, okay, and in the weekends. So likewise, right. So backlogs, if you are able to willing to clear the backlogs, there is no gating item for learning. Okay, end of the day, when you clear the backlogs before you enter any company, because they will your technical interview have cleared, but HR round you have to show your certificate, right, your passing certificate. So that is important, so that you have to take care. The rest training is doesn't have any constraint if you have backlogs or not. Okay, so yeah, uh, can you talk with any of the
Sir,
alumni of Success Bridge? Yes, yeah,
I
please go ahead.
see
Somebody,
integrated circuit. I see
sorry.
integrated circuit. I see integrated circuit.
Yes, I didn't understand your question, Roman. I think you can ask me again. You can.
Sir, what are I see? I see integrated circuit.
Yes, it's IC is an integrated circuit. Okay, you can connect to the HR or front-end team of Success Bridge. Okay, we'll try to communicate to you again if you have any queries. So in this forum, any questions that you have related to your course, please do ask. So anybody passing out of 2025, yes, you can still join the course. DFT and DV, which one required more coding? DV. DV needs strong Verilog coding skills because you need to write the test bench for that. So design verification engineer is the one who writes test bench to
Monitor,
target the RTL
TFT
code.
monitor. Sir, TFT monitor.
Yes. So uh, domain change impact in getting recruited. Yes. Domain change in terms of, I mean, if you are a software engineer, if you want to come to semiconductor, no, there is no such thing as impact. Many people, HRs or people, when they try to interview you, having a software background or any other background previously, they actually consider your experience as an industrial experience, if it is a proper industrial experience, any kind of industry. So semiconductor has it. Your master's is considered as an experience. Your industrial experience is considered as an experience. So that is how you portray it. Like if you are technically good in learning physical design, when you give an interview, you can take a stand of what you have done in masters or your other industry. That will not impact. Actually, they like it. Your passion towards coming into this domain, they like it. So how do you answer to a question? Why did you change the domain? That you have to take care. That's it. Okay.
The tool access will be for 4 months, sir.
Tool access will be throughout the course and even after the course until you get placed. Okay. Yes, course content topics. I can, yes, I can just share you. Let me check with the trainer if trainer is able to share. Arushi, can you share the course content?
Yes, just a minute.
Yeah.
Yeah, in the meanwhile, I think Ganesh, there are a couple of questions which you need to. So, someone is asked about, so do you get placements from the companies listed in our website only? So actually, the list which
Yeah,
you
I
have
have
mentioned
answered.
over there, it's not the entire list. We have more companies other than the website which you have mentioned. I think which
Right.
or Ganesh has already answered. Okay.
Okay, so the next batch is starting. The physical design demo is provided. The reason is that we are going to start a physical design batch going soon, coming soon. I think within the next one week or 2 weeks. Within that period only, we are going to
Yes,
start a
I'll
new
answer,
batch.
Ganesh. So actually, guys, so this physical design demo is going to be we have started this demo for the to start a new batch from April 8th. Okay, so we have a 1 week time to do the registrations. So as it, I just want to take up some time of yours to just take up what is the difference, what is the uniqueness of Success Bridge. So what is the specifications of a Success Bridge? Basically, as most of the topics already Mr. Or CTO Ganesh already covered. So our specifications compared to other institutions is we have the trainers; those are the industry experts. They are not the real-time trainers. Take example of Arushi, who is a physical design trainer. She has approximate more than 8 years of experience and she's working in one of the product-based company. So she's going to take up the upcoming 3D physical design training batch. So we basically work on the industry EDA tools, as our CTO told. He, the tool success will be provided to you till you get placed. Okay, and we work on the real-time projects, and there will be something called module-wise assignments. Like we have different modules in physical design itself, which Arushi will share you the content now. So the after every module, we'll be having a like an assignments, which will help you to work out on your technical skills. And we'll have something called soft skills, communication sessions with or group presentations, individual presentations, which we pretty much require. And the one more thing, what is uniqueness of us, is the maximum count of a batch would be the 20 students, not more than that. We are not like other institutions who will go with more than 50, 60 people. No, we'll go the maximum count is the 20 students of a head count, which will help us to give the individual focus and the placement purpose as well. You yourself can think over it, right? The people who have 80, 70 people, how many of them are going to place? So maximum count would be 20 students. And after after completion of this trainings, we'll have the mock interviews by the industry experts and individual focus. As our CTO told, we basically offer the affordable fee. Okay, actually our fee was supposed to be 80K, but now we have something called our Make in India offer. So we are giving up to 25% of offer. Who is doing the early registrations? Because as I told, we have 20 as an head count. We almost done with 12, 13 registrations. Because in each and every batch, we'll get people from our previous batches references itself based upon our quality part. So we have very limited seats available to do the registration. So if you wanted to avail this Make in India offer, please do the registration as soon as possible. And the placement part, we will help the people till they get placed. This is one of the uniqueness which compared to other institutions. Okay, and I want to answer one more question here, which someone asked me. Yes, we will provide you the contacts of our previous people who have got trained and placed. You can talk to them. As I told, next batch would be the current physical design batch is going to be start from the 8th of April. So please start doing your registration, or administration sales team will be in touch with you. Yeah, Rishi, please go ahead.
Yeah, Yusuf. I'm sharing the curriculum, so you can see that
Yes.
what are the things you can
Yeah.
support.
Thanks, Arish. Please just share the screen. I'll be going through that. Okay. Here, as you guys can see, physical design is the backend of semiconductor, where you physically design a circuit using the tool. Okay. So we use tools to design an IC, and whatever the RTL code is written, okay, to design a mobile phone or any IC that you want to design, that IC, as physical IC that you are able to see, because physical design engineers are going to design it, okay, using the tool, all the transistors in one place using this flow. Okay, so digital electronics, CMOS basics, coming from ECE, EEE backgrounds or VLSI background, for them it is more feasible. Okay, you have to have uh, this background of digital electronics. Okay, at least you should have awareness of digital electronics. That is a prerequisite. Okay, but still, after joining the course, we will be going through initial training on digital electronics. Okay, and a CMOS. Next, Linux. Linux is a environment where we work. Okay, so semiconductor is very much confidential and IP secured. Okay, so even not just semiconductor, any even a software, they all work in a Linux operating system. So even though you have a Windows operating system in your laptop, you can use a virtual machines. Okay, we called there are many types of VNC or many other uh, virtual machines that will help us to invoke the Linux operating system and work there within a Windows operating system. Okay, so it's just a tool that we install in our laptop, and we'll be able to access a Linux operating system and work there. So there is a different working experience with the Linux operating system. You need some basic commands to copy, move. Everything you do in Linux is through command. So that commands you will learn. We will help you with that. Next, there is a tickle programming understanding that we need. Okay, because all tools in semiconductor are compatible, and they use tickle programming as a basic programming. So their commands itself, the tool commands. Let's say you are asking the tool to do a floor plan. Okay, the commands are more feasible in terms of tickle programming. Okay, so we should have a basic understanding. Tickle is the easiest scripting language that we use. Okay, uh, and it will have the for each loops, if else statements, and very basic, not the software tickle that we software people use. We use the very basic commands, how much is needed for us. Next is static timing analysis. This can be learned as a initial course or in the end of the course, depending on the trainer flexibility. So this is a static timing analysis part of your course. Okay, so here you will be learning how to do timing analysis on a design. Okay, so that will you will be learning in STA. Next, so physical design, this is the actual full course that you are going to implement. Okay, you're going to learn. You learn about ASIC flow, synthesis, your physical design flow. Okay, design setup, how do you start with? Okay, and floor planning, power planning, placement, and clock tree synthesis, CTS, routing. Okay, after that you move on to physical verification. Okay, so uh, these are the stages where you do and you learn part of your physical design course. And in real time, when you get a job, you might be doing a few of these, not all, because you work as a team. So let's say there are 20 or 30 people, or just 5 people in the team who is handling one project. Okay, so each person has to handle a single partition. Okay, single module. Okay, for that you have to do all these steps using the tool. Okay, so there will be scripting available already in the flow. Okay, so you have to understand how the script is written in the tickle programming or basic Linux scripting. Okay, so all this you will be learning part of your course. Right, any other questions? And please do fill the form so that any queries you have, we can able to communicate to you. Okay, any other demo sessions that are going to happen, any other courses or related to anything that you need. Okay, fee structure, any career guidance you need, job placement assistance you need. We should have your information so that we can contact you. Okay, please do fill the form. Okay, and we will try to communicate to you frequently where we have anything happening within Success Bridge on any new courses happening like DV, DFT, PD. Okay, we will let you know. Okay, please do fill the form within the chart.
So form is in the group WhatsApp or
In this group, in this meeting chart.
Okay, sir. Little chat.
Please go through the form. I think there are many comments. Please go to the very beginning of the chart window. You will be able to see forms. Okay. Right. Somebody is asking about, one moment. Yes. Once you fill the form, we will let you know when is the next DV demo class. Okay. Narsimha. Okay. And Krishna, about the interview process. So interview process will be like, as I said, you should be a trained engineer, trained in a particular domain, physical design, DFT, DV, likewise. So once you're trained, your interview will be basically on the uh, your particular domain that you have learned, and you should have that domain expertise. Second, your skill set is in semiconductor. The skill set is Verilog, your RTL coding, the basic Verilog programming is a skill. Okay, you should know C, C++, Java. You don't need them. You need Verilog, and you need whatever we teach you in the course, like Tickle basics, Linux basics. All these are the mandatory skills. Okay. Yes. So uh, any company in the semiconductor or software, when you join, okay, so if they are hiring you, they as a fresher, as a trained fresher, they expect you to work for at least minimum 3 years within the company. So there will be a contract for some few companies. They expect a contract of 3 years. Okay, so for them, uh, they give those who have a contract, they are well paid actually. Okay, because in contract they mention that this particular year the pay will be like this, or next year their pay will hike will be like this. Okay, so first 3 years you will be spending time in learning, understanding, gaining the skill set. So in industry, every time you change the company, you move from one company to another company, they check how long you have stayed in a company. You are frequently changing, then you are not stable. They will not hire you if you are not stable in a company at least for 3 years. So first 3 years you should always be stable. Okay, so you are changing frequently, and you are not even stayed in a company in your beginning of the career for at least 1 year or 2 years or 3 years, then they do not hire you. So that is a very biggest impact. So companies by default, Wipro, HCL, signed any company that you take care. Okay, when you join as a fresher, trained fresher, they expect you to have a 3 years of a contract. So based on that, you will be able to join. Okay, unable to open the Google form. It's showing dynamic link not found. Yusuf, can you check this? Yeah, we'll recheck and see what is the issue with the form. I think we are able to access it. I just clicked it. I'm able to access it. Please check. You should at least have a Gmail account to access this Google form. It will be more convenient. Yes. Chanchal, any other questions? Anybody have question? When will be the openings available? Openings are available always. There is no such thing as less openings or nothing like that. As I said, semiconductor needs more hiring. More hiring is happening. There are many companies. People actually doesn't know how many semiconductor companies we have in the India as of now. how many are in Hyderabad, how many are Bangalore, Pune, New Delhi, okay, Ahmedabad. So there are many openings. Okay, I am already in the industry, and I said companies approach us for, do you have any trained freshers with you? We are hiring. Okay, so all the companies don't actually post publicly. Okay, they approach training institutes requesting trained engineers. Okay, when you publicly post that I am hiring, what happens is, with eligibility or without eligibility, all come in, sit in one place. Okay, so again, it's a problem for the company to waste time on filtering the resumes and all of these, and then start hiring process. It's a time consuming. So people don't do that in semiconductor. Very few companies, to showcase that they're hiring, they do it, and majority of the companies, they don't post publicly. Okay, they approach to training institutes asking for, uh, you have a training fresher, please do send us. So we tie up with the company, so HRs of the companies directly interact with the training institutions. Okay. Yes, every day recording will be there. We provide you recorded session. Okay, every session that is happening will be recorded and provided to you. We'll provide you the notes, tool manuals, materials needed to access the tool, understand the course. Okay, the course content, everything will be provided to you. Okay, you can access it anytime. And those who are interested, as I mentioned in the text before the chart window, physical design course is physical design is a high priority domain in the entire semiconductor. Okay, highly valued in the semiconductor society. Okay, if semiconductor is there, still there, that is because of physical design. DFT came into picture on a later stage where design complexity is increasing and they need more yield, in the sense, like if they are manufacturing 10,000 mobile phones, out of them only 5,000 are getting working fine after manufacturing, then the company loses a lot of money, billions of money. So in order to avoid the wastage, okay, IC wastage, or a lot of money invested on that, okay, DFT is needed. So DFT comes into picture on a later, in the early 2008 9, and more active after 2012. But physical design is the core domain which was there from the very beginning. You have to write an RTL code, then you have to go through the synthesis, floor plan, routing. This is the this is the core domain of a semiconductor. If you want to design an IC, a physical design engineer has to be there. This is the highest valued domain in the entire semiconductor. And as I said, 85% of the work is done by the tool. Okay, 15% of the work is done by the engineer. Have to handle the tool, control the tool. If a tool is designed, they will give you tool. Since Synopsys is a tool vendor, okay, EDA tool vendor. So this tool vendor will provide you the tool manual. We have to work with the tool manual. We have to understand the user guidelines, okay, commands, and all of this part of this course content. Okay, and just in interview, the questions will be more on the tool, how you are handling this, how you are placing this. Okay, all these questions will be more on the tool and the concept. Okay, so it's very good if people are interested in circuit designing, they choose the physical design, and it's more interesting actually, and passion. Those who are passionate into learning can learn this. And now, due to global awareness, we have more hiring happening across the world. As I said, if you have a 3+ of stable work experience in a single company, you are more preferable. If you stay in a company for 3 years, you are more preferable. Okay. After that, you can change every 2 years if you want. First 3 years is a strong pillar for your profile. You have to build your profile strongly, so you have to stay in a company for 3 years minimum. Then you can, companies will come to you actually. So offline classes start, we'll let you know in the form. Please do let me know if everybody are able to access the form in the Google, I mean, in the chart window. Can you say yes? So we'll understand those who are able to access and those who are not able to access. So mention that you need online class or offline class, which timings are preferable and all that. Okay, so we'll get back to you on that. And Brahma is asking some in VLSI layoffs are there in like IT industry. Like IT industry, VLSA will have layoffs or will not, depending on the what we call the global issues. Like there was an issue 3 years back due to COVID. Imports and exports were jammed. Many projects got scrapped. Okay, so because of that, we have seen a, a big layoffs happening because uh, there is a wars happening across countries. Okay, and chip shortage because of COVID, import and exports. Okay, so all this brought the issue, but unlike IT industry depends on the dollar fluctuation, so we don't depend on dollar, we depend on pandemic issues. If there is a pandemic, there could be an issue, but other than that, we don't have an issue. Okay, and uh, freshers are never. I'm being very straightforward. I'm telling you, any company will not remove freshers because freshers are the lowest paid within that payroll company, right? So you have a senior who is more paid than you. You have the senior has a one more lead manager, director. Okay, so layoffs will start coming from the high top to bottom, not from bottom to top. If they remove a trained fresher or a fresher, what they will get? Nothing. They cannot. I mean, their budget will not just give a spike, right? So layoffs happen in semiconductor from top to bottom. Managers are the first who get laid off. If he is needed, if there is a project needing of that manager with high pay in terms of CR, in terms of crores, because managers are paid in crores. If that manager is not needed, first he will be laid off. And if there is a senior lead person who is not performing well or he's inactive, okay, he might get laid off. So other than that, there is no. Unlike IT industry, we don't depend on the dollar fluctuation. Okay. In the 25 years, in the past 25 years, because of the pandemic, we have seen some such things, but there was never a layoff happening in the semiconductor. Which country hire more VLS engineers? As of now, India. Okay, next is Malaysia. Third is Europe. Fourth, China. Fifth, Japan. Next, US. more resources are within India, so more companies are coming, growing up. Semiconductor is growing like anything in India now. It's the funding is very high. Okay, that's it then. Please go with the Google form, fill up, and post your questions, queries, info. So our team will get back to you based on what you how you fill the form. Okay. And if you have any queries, please do Google Success Bridge contact. Please take the contact information and please do contact us. We're always available in the working hours. Okay. Thank you.
Thank you, sir.